Hello guys and welcome to another lesson of Mossy Maths with me, Tom Moss, and today we're going through the second lesson on the topic of coordinate geometry, which is again part of the Core 1AS Maths course, and today we're going through midpoints and distances of line segments. And we're going to be going through 4 questions taken from the latest AQA revision guide. These 2 based on midpoints and these 2 based on the lengths and distances of lines. This is again going to be quite a long topic, probably about 5 or 6 lessons. We're going to need to know about 2 key points, which come in the form of 2 formulas. The first one is for finding the midpoint of a line segment. So the midpoint of our x coordinate is x2 plus x1 divided by 2, and the y coordinate of our midpoint is y2 plus y1 divided by 2. All this means is that if we're given 2 pairs of coordinates, then we can work out the x and y values of our midpoint from that. And the second formula is Pythagoras' theorem. Hopefully you notice this from GCSE. A squared plus b squared equals c squared. Now this can be used to find a missing side of a right angled triangle. And this is relevant when we're finding the distance given pairs of coordinates. So let's get started straight with the midpoints question. The point A, 7, 4, and B, minus 1, minus 2, are points on a line segment, and we're told to find the midpoint of the line segment AB. Okay? So with these questions, I find it helpful to draw out a diagram. And it doesn't have to be accurate, it doesn't have to even be relevant to the coordinates in the way that it's drawn. It just helps us to visualise what we're going to have to do to answer the question. If that's the point B and that's the point A, then this could be our midpoint. So hopefully we can see that to find the midpoint of these coordinates, we have to consider both the x value and the y value. So the x value of our midpoint is going to be in between minus 1 and 7. Now the number in between minus 1 and 7 is 3, so our x value of our midpoint is 3. Now the y value of our midpoint is going to be in between minus 2 and 4, which is 1. So actually we can see when we draw the diagram what our answer is going to be, without really having to do any working out. But for those of you that are less familiar with this topic, you might find it more useful in an algebraic form, which is why I'm going to use this equation here. So first considering this one. Our midpoint of our x value is going to be the second x coordinate, which is minus 1, plus our first x coordinate, divided by 2. Now, once again, it doesn't matter which order we add these. If we add 7 to the minus 1, we get 6, and if we add the minus 1 to the 7, we also get 6. So the answer is the same whichever way we add these. So we're going to get 6 divided by 2, which is 3. So therefore 3 is our x coordinate of the midpoint. Now we consider our y value of the midpoint, which is going to be, well, 4 plus minus 2 divided by 2, which is 2 divided by 2. This is just 1. So therefore we've got an x coordinate of the midpoint being 3 and the y coordinate being 1. So we can now draw out a coordinate, which is going to be the point 3, 1. So this is our midpoint, okay? Right, if you like, you can pause the video and have a go at this question at home, and I'll go straight through it with you afterwards. Okay guys, hopefully you've paused the video and had a go at home. This question says the point y, which has coordinates 6, minus 6, and the midpoint m, with coordinates 4, 0, are 2 points on a line segment xy, and we're told to find the point x. So let's draw this out again. Say this is our x, and this our y. Well, y is 6 minus 6. Our x is unknown, but we know our midpoint, which is 4, 0. So in this question, we're told the midpoint, but not the coordinates of the point x. So we're actually having to see what we're doing from this to get to this, and then do the same thing to get to our x value. So what I mean is, what do we do to get from 6 to 4? We minus 2. So to get from here to x, we're going to have to do the same thing, minus 2 again, but this time from 4. Well, 4 minus 2 is going to give us 2. Here we're having to add 6, minus 6 add 6 gives us 0. So if we add 6 to 0, we're going to get positive 6, which will be a y-coordinate of the point x. So we can actually, again, find this answer just by looking at the diagram we've drawn out. But we're going to do it in this form and rearrange. So if we consider this one, then the x-coordinate of our midpoint is 4, and this is equal to 6 plus our x-coordinate of the point x, which is unknown, divided by 2. So we can now rearrange this to get x. If we multiply both sides by 2, then we get rid of the fraction. 4 multiplied by 2 is 8. And this equals 6 plus x. So if we make x equals, then we're just subtracting 6 from 8. X is 2. And we now consider the second equation. So the y-coordinate of our midpoint is 0, and this is going to equal minus 6 plus the y-coordinate of the point x, divided by 2. 0 multiplied by 2 is 0. This equals minus 6 plus y. So we simply move the minus 6 across to get positive 6. This equals y. So y is 6. And we can say therefore that the coordinate of our point x is going to be 2, 6. So there's the answer to the second question. Now let's consider the third question. This looks at finding the distance and therefore the length of a line. And this concerns using Pythagoras' theorem, and I'll show you why this is relevant to the question as we go through drawing the diagram. So if this is the point Q and this is the point P. Well, if we were to go about finding the distance we've travelled in the x direction, then we'd have to find the difference between 6 and minus 1, which just means we subtract minus 1 from 6. Well, 6 minus minus 1 is 7. And to go about finding the length in the vertical plane, well, this is going to be 2 minus 0. 2. But what we want is the distance here. We want PQ, not the individual x and y value distances. So we need to actually apply Pythagoras to this because we've created a right-angled triangle. So we can call our A either 7 or 2. If our A is 7, then 7 squared plus B squared, which is going to be our 2 squared, is equal to C squared. In this case, we're going to call C the line PQ squared, because that's the line concerned with the question. So, 7 squared is 49, 2 squared is 4, and this equals PQ squared. So PQ squared is going to be 53. So if we square root both sides, we get the length of PQ. So the length of PQ is just a square root of 53. And it's important we leave the answer in this third form, because the square root of 53 is not easy to calculate without having a calculator. And in a Core 1 exam, you won't be allowed a calculator. So we do leave it in this third form. So there's our answer. Now with this question, if you like, you can pause the video and have a go at home. However, this is slightly more difficult, and you have to read the question very carefully to make sure you do the right thing when working out the answer. So with this question, it says the point U, which has coordinates 3k, and V, with coordinates 15, 6, are 2 points of the line segment UV, with length 13. And we're told to find the possible values of k. Now, this part here is particularly important with this question, where it says the possible values. Now, with this being plural, it tells us that we're going to get more than one value of k. So we know that if we end up with one value of k, we've done something not completely correct. Again, if we do get one value of k, then we're likely to pick up maybe 3 out of 6 marks, or potentially 4 out of 6 marks, but we really need to be finding 2 answers, and I'll show you how we do that as we go through the question. So to start with, let's begin by doing exactly the same thing as what we did here. We found the distance between the x coordinates? Well, the difference between 15 and 3 is 12. So this can be our a squared. Now our b squared is the distance between our y coordinates, which is the difference between 6 and k. So to do that, we'd do 6 minus k. Just like to get 12, we did 15 minus 3. So our b squared is 6 minus k squared, and this is equal to our c squared, which is the length of the line. In this case, we're told that that's going to be 13. So this is equal to 13 squared. Right. So at this point, it would be best, in my opinion, to simplify what we have. So 13 squared is 169. 6 minus k squared plus 12 squared, which is 144. And now we can simplify this down even more. Well, 169 subtract 144 leaves us with 6 minus k squared on this side of the equal sign. 144 subtracted from 169 gives us 25. And this is the point where many people might make a mistake. It's a temptation here to square root both sides, because we have this squared, and if we square root both sides, then this 25 does simplify easily. The square root of 25 is just 5, so we'd end up with 6 minus k is 5. And if we went on to solve that, we'd get a value of k equal to 1. And that's why this is not the right thing to do. Because again, referring back to the question, it says the possible values of k. We're going to get more than one value of k. So we can't do that here. So therefore, the only other option for us is to expand this bracket. If we do that, we get 6 times 6, which is 36. Minus k times minus k is positive k squared. And minus 6k minus 6k is minus 12k. So we end up with k squared minus 12k plus 36 equals 25. So, we can now simplify this down again. If we subtract 25 from 36, then we make this quadratic equal to 0. And hopefully you've watched my previous video on quadratics, where we looked at factorisation. If we make a quadratic function equal to 0, we can factorise it. So if we do that, we get k squared minus 12k. Now 36 minus 25 is 11, and this is equal to 0. Now we know we've done the right thing, because we're going to get two values of k. Whenever we have a quadratic that we factorise, we get two possible values. And this is what the question asks for. So if we factorise this, hopefully we can see that we need to find two values that multiply to give us 11 and can add together to give us minus 12. Well, the only possible option is minus 11 and minus 1. Minus 11 times minus 1 is positive 11. Minus 11k minus 1k is minus 12k. And k multiplied by k is k squared. And we now make each bracket equal to 0. So if k minus 11 equals 0, then k is 11, simply moving the 11 across. And if k minus 1 equals 0, then k is 1, simply moving the minus 1 across. So the two possible values of k are 11 and 1. And it might be a good idea to then state that k is 1 or k is 11, just to clarify that they're the two answers you found. So as you can see, the 1 was correct, so if we did then square root at this point, we would get this answer correct, but we wouldn't get the k is 11, and therefore we would certainly drop marks in an exam. So we have to actually expand these brackets. So that's lesson 2 on coordinate geometry. Thanks a lot for watching the video. If you found it helpful, please put a like. If you do have any questions, please put a comment below and I'll get back to you as soon as I can with an answer. So that's the second lesson on coordinate geometry. I'll see you in lesson 3 on the same topic.